All right, so I need you guys to turn to page 9 in your trig packet for Unit 2. So it should be the front side of the last page. And today what we're going to do, we're just going to do some problems out of the homework section, and then you're just going to finish what we haven't done on these last 2 pages. All right, so on example 4, or number 4, we are going to find the values of all these expressions. We're not going to look back at our charts where we've already done the work. Hopefully you guys have. If not, you need to do that. We are just going to draw a little picture every time and then calculate the values. So on number 4, these are all quadrant angles, you can tell. So to draw the pictures for quadrant angles, it's just the coordinate plane. They're points on the quadrants. Right? So for 90 degrees, we're going to use the point 0, 1. And then for 180 degrees, we're going to use the point -1, 0. And so what I want from this these ordered pairs is the sine of 90 degrees, and I want the cosine of 180 degrees. So the sine of 90 degrees, when we're using x, y, and r to find the sine, we do y over r. Now because these points are all 1 unit away, r is going to be 1. So for sine of 90 degrees, it's 1 over 1, or just 1. All right, and then the cosine of 180 degrees. Oh my goodness.
Ashton Toller, please report to the main office. Ashton Toller.
For the cosine of 180 degrees, it's x over r, and x is -1. So -1 over 1 is -1. So I'm just going to put 1 in for the sine of 90 degrees, and then I'm going to put -1 in for the cosine of 180 degrees. So we have 5 times 1 minus 7 times -1, or 5 plus 7, which is 12. Okay. All right, let's look at C. C is same thing, just a different expression that we're going to do. So 180 degrees is the only angle we need. We just did 180 degrees, but we'll draw it again just for practice. So 180 degrees is here. That point would be -1, 0. All right, so I need the sine of 180 degrees. So we are going to do y over r. So y is 0, r is 1, so that's 0. And then since we just did the cosine of 180 degrees, we'll just bring it down. So the sine of 180, well, hold on, let me draw that a little bit better. All right, so the sine of 180 degrees is 0, so I need 0 squared. The cosine of 180 degrees is -1, so I need -1 squared. So 0 squared is 0, -1 squared is 1, so that's just going to be 1. All right, now we're going to do E. So same thing, 0 degrees and 270 degrees are both quadrant angles, so we'll just draw our x-axis and our y-axis. 0 degrees is here, 270 is here, so that's going to be the point 1, 0 and the point 0, -1. Now we need a lot on this one. We need the sine and cosine of 0 and the sine and cosine of 270 degrees. So you guys use the points and the x, y, and r rules to find those values for me, please. Okay, then I'm going to go back and just plug in everything. So the cosine of 0 degrees is 1. The sine of 270 degrees is -1. The cosine of 270 degrees is 0. And the sine of 0 degrees is 0. So it's 1 times -1 minus 0, or just -1. All right. So we are going to do some on number 5, but since number 4 and 6 are similar, we're just going to kind of skip that and we'll just move around a little bit differently. All right, same thing. So we're going to draw a picture to find these values and then sub them in. So these are not quadrant angles. So these are going to be like triangles that we need to draw. So we need to draw a 30-degree triangle and a 150-degree triangle to do A. So 30-degree triangle is in quadrant 1. So for 30, 60, 90, opposite of 30 is 1, hypotenuse is 2, opposite of 60 is square root of 3. And what I need from that triangle is the sine of 30 degrees. So quadrant 1, I don't have to worry about negatives, so I'll just do opposite over hypotenuse. The sine of 30 degrees is 1/2. Okay, I'm going to move over here to do the 150. All right, 150 degrees is in quadrant 2. I'm going to need a reference angle. So since it's on the 180 side, I would use 180. And since 180 is larger than 150, it's going to be 180 minus 150. So that gives me a reference angle of 30 degrees. Opposite of 30 degrees is 1, hypotenuse is 2, opposite of 60 is the square root of 3. All right, and then what I want from this one is the cosine of 150 degrees. So in quadrant 2, cosine is negative. And it's going to be the square root of 3 over 2, the negative square root of 3 over 2. All right, so now I'm going to take those two things I found and plug them in. And then I can kind of reduce that down a little bit. Well, I know 6 times 1/2 is 3. I know a negative times a negative is a positive. All right, and then the 4 times the 1/2 is going to give you 2, or you can think of it, it reduces down to 2. So that's going to be 2 square root of 3. All right, let's look at C. So I need to draw a triangle with a 120-degree angle and then a separate triangle with a 225-degree angle. So 120 degrees is in quadrant 2. To find my reference angle in quadrant 2, I do 180 minus 120. 180 minus 120 is 60 degrees. That's my reference angle. Right? So I know that if that angle is 60 degrees and I have a 90-degree angle, that this angle is 30 degrees. And I know opposite of 30 degrees is 1. Hypotenuse is 2. Opposite of 60 is the square root of 3. Right, what I want from this triangle is the tangent of 120 degrees. And to find the tangent, well, first, in quadrant 2, tangent is negative. And the tangent of 120, we would do the opposite over the adjacent. So it's the negative square root of 3. Right, 225 degrees is in quadrant 3. Right. In quadrant 3 is still on the 180 side of the coordinate plane. And so we would do 225 minus 180. And that's going to give us a reference angle of 45 degrees. So that is 45, 45, 90. Our two legs are 1, and our hypotenuse is the square root of 2. Cosine is negative in quadrant 3. And I will do the adjacent over the hypotenuse, which I know reduces to the square root of 2 over 2. And then I'll just plug in. All right, so let's go ahead and reduce inside and then multiply. So that's going to be negative 4 square root of 3 times negative 4 square root of 2. Then when we're multiplying, we would multiply the numbers outside together. So negative 4 times negative 4 is 16. And then the square root of 3 times the square root of 2 is 6. All right, a few more. So you guys go ahead and draw the triangles you need for E, please. All right, so in quadrant 1, cosecant is definitely positive, all positive. So for cosecant, it's going to be the hypotenuse over the opposite. Okay, tangent and cotangent are negative in quadrant 4. Cotangent is going to be the adjacent over the opposite. Then I'm ready to plug in. Okay, so that would give us negative 16 over the square root of 3, which I would want you guys to reduce down to negative square root of 3 over 3. All right, G is kind of nice because we only need one triangle because the only angle we see is 225. And we've already done one with 225, but let's just draw it again because the more practice you guys get with this, I swear it's going to be easier and easier. So our reference angle ends up being 45. So you guys go ahead and write down what you think the sine and cosine of 225 degrees is. All right, and then we'll put those both in, and we're going to square them. All right, when you square the negative square root of 2, you just get 2. When you, well, actually, we don't even have to do all that. We could, but when the negative square root of 2 over 2 squared minus the same thing, that's just going to give you 0. All right, one more. So for I, we have the sine of pi over 6 and the cosine of 2 pi over 3. Now, I don't really want to try to do this with radians, so I'm going to change these radians to degrees. And so 180 degrees divided by 6 is going to give us 30 degrees for pi over 6. Okay. And then 2/3 times 180, or we could do 2 times 180 divided by 3. Either way, it's going to be 120 degrees. All right, so we have 2 triangles. Let's see if I can fit them over here. Okay, so we are going to have to subtract these inside these parentheses. So I am going to leave this for, like, when we multiply a negative times a negative, it's a positive, but then just multiply 4 times the 1 and leave it like that, because I have to have a common denominator to add those. So when I do add them, I get 5 halves. And then when I square that, I get 25 fourths. All right, so we could have multiplied -4 times -1/2 and just got 2, but then we would have to find a common denominator. So I just kind of thought ahead a little bit. And don't forget, when you square a fraction, you square the numerator and the denominator. All right, we're going to go back up and do one more thing. I know this is kind of a lot for one day. Let's talk about the range of the 6 trig functions. So the range is what comes out. So like when you take the sine of something, what you actually get. And so for the sine and the cosine, they're always dividing by the hypotenuse. And the hypotenuse is the longest side. So if you divide a shorter side by a longer side, it's never going to give you anything greater than 1. And it's never going to give you anything less than 1. So the range of sine of theta and cosine of theta are both values between -1 and 1. So on the quadrant angles, you don't necessarily get triangles. And so that's where you can get the -1 and the 1. But on all the angles that create triangles, they're going to be less than 1 or greater than -1. So fractions, usually fractions or decimals between -1 and 1. But on the quadrants, that's where you can get the actual values, -1 and 1. All right, for the cosecant and the secant, it's just the opposite of that. On these, the larger number is on the top because the hypotenuse is always on the top. So a larger number divided by a smaller number should give you something greater than 1 or less than -1. So our range is going to be from -infinity to -1 and from 1 to infinity. Right? And then for tangent and cotangent, it could be either way, like for larger and smaller. So you're doing the opposite divided by the adjacent and the adjacent divided by the opposite. So you don't know which one of those is bigger or smaller. So the range on the tangent, you could get anything. So as long as it's a real number, -infinity to infinity. All right, so we're going to do A, C, and E together, and we're just deciding if it's possible that this could happen. So is it possible that you could take the sine of an angle and get -5? Well, no, it's not, because when you take the sine of an angle, you have to get something between -1 and 1. -5 is not in that range, so we would say that this is impossible. All right, C is a little less straightforward. So we're going to do something that I don't think you guys have ever done, and we're going to kind of solve a trigonometric equation. So we want to solve this trigonometric equation for the cosine of theta. So the first thing we would do is subtract that 5.5, and we would get -1.5, and then we would divide by 2. So -1.5 divided by 2 is -0.75. All right, so is it possible to take a cosine of an angle and get -0.75? It is, because -0.75 falls between -1 and 1, so that is possible. All right, and then for E, we want to know, can we do the cosecant of one angle, alpha, and add the sine of another angle, beta, and get 0.5? And so this is a little harder. So what I usually do is I try to pick values that are in the range of the cosecant and the sine and see if I can work them so I can get 0.5. And you can. So what I can do is go to this part of the range of cosecant and use 1. And then go to the range of sine and use -0.5. And those two add to give you 0.5. So it's possible. All right. So you guys are going to do the things we haven't done. Now on this possible and impossible, don't forget that with tangent and cotangent, it could be anything. So if we're talking about possible or impossible with one of those, automatically possible. If tangent or cotangent are in there and it's a real number, it's possible. All right, so what I want you guys to do is go back on page 9 and do B, D, and F that we haven't done. B, D, and F on number 5, and then B, D, F, H, and J on number 6. So we're going to finish numbers 4, 5, and 6 on pages 9 and 10.